Students, myself Sanjeev Kesari Tripathi, I am from MKD Education. Today I will going to teach you physics. I am expert of physics from MKD Education. Basically we are going to teach physics which is included in the diploma courses. The first basic concept of the physics I am going to be explain to you, that is unit and dimensions. Today we will now going to be start. What is physics? Physics basically deals with the natural science or natural phenomena which is occurring around us. So physics is a basic discipline of natural science which is governed by the basic law of nature and which explain the fundamentals of some activities which is carried out in the day-to-day lives. Then we will going to be explain what is its outcome, and the basis at the outset of the class student we know about the concept of the physics and how the physics is related to our different aspect that we are going to be explain, and different physical quantity and their classification, how will be explained, how will be expressed to somebody, some layman or some in day-to-day lives. For examples, I will go to that physical quantity which is generally explained in science. What is physical quantity? First I will going to be explain you. Suppose I will ask to a shopkeeper, please give me 5 kg of rice. This 5 kg which indicate a physical quantity. So physical quantity require two things. One is magnitude, which is pure number, and another is unit of expression, which is kg. So these two things which is very important to express a physical quantity. It will only say please give me 5 rice. That does not mean anything. It will simultaneously say please give me 5 kg rice. This physical quantity give a sense to another persons. So this physical quantity which is deals with the basic concept in physics. So therefore there are two types of physical quantity. One is fundamental physical quantity, another is derived physical quantity. And this quantity, in order to express, we require unit, that is which I explained to you, that is kg. So in physics there are 4 system of units. One is ICh system of unit, another is FPS system of unit, another is MKS system of unit. Another is international system of units, which is the modified version of MKS unit system. In these systems, there are 3 fundamental quantity in FPS system, another is ICh systems, another is MKS systems. In these 3 unit systems, there are 3 fundamental quantity. One is mass, another is length, another is time. So first F stands for foot, P stands for pound, S stands for second. In ICh system, C stands for centimeter, G stands for gram, S stands for second. And in MKS system, M stands for meter, K stands for kg, S stands for second, which define these 3 fundamental quantity, that is length, mass and time. So except this, according to these systems, except these 3 physical quantity, all are derived quantity. But these 3 fundamental quantity unable to fulfill our requirement, that is in physics. So therefore these MKS systems, which is modified to SI unit systems. In MKS systems only there are 3 fundamental quantity, or in ICh system there are 3 fundamental quantity. But in SI system more fundamental quantity are added. As you will be seeing in the slides, that is length, which is L, and mass M, another is time T. Another fundamental quantity which is added, that is temperature, which is measured in Kelvin. Another is electric current, whose unit, SI unit is ampere. Another is luminance of intensity, which measures the brightness of light, whose unit is candela. Another is amount of substance, which is unit is mole, and the symbol is written as length symbol is L, mass symbol is M, time symbol is T, temperature symbol is K, and electric current symbol whose unit is ampere is A, and luminous of intensity whose unit is candela symbol is CD, and another is amount of substance which measures the use general, basically it is used in chemistry, whose unit is mole and symbol is MOL. So that means there are another 4 fundamental quantities added in SI system. So therefore there are 7 fundamental quantities according to SI unit systems. Then these are called primary fundamental quantity. Primary fundamental quantity. Apart from that, there are another 2 fundamental secondary fundamental quantity are there, which is that is angle. Generally we will measure an angle which is measure is radian. That's unit is radian. Another is solid angle. I will show you what is solid, which is a 3-dimensional angle. It will fold this paper. It make it just like a cone. And this angle which is formed by the cone is called solid angle. And which SI unit is steradian. That is, one is angle, another is solid angle, that is SI unit is steradian. So I am going to write that is angle is that is radian, generally RD is written, symbol, another is solid angle which is unit is steradian, STRD, that is steradian, which SI unit is steradian. These 2 are secondary fundamental quantity which is included in SI unit systems. Because this, except these 2 things, other quantity, other unit are termed as, that is derived fundamental, derived physical quantity. So therefore this physical quantity which is written is dimensional variables, dimensionless variables, dimensional constant, dimensionless constant. So then again it is same way it is divided into, this is 4 types as you see, that is dimensional variables, that is, and another is dimensionless variables which has no dimension, and certain physical quantity is constant, just like is a gravitational constant, that is G, and acceleration due to gravity you know, whose value is 9.8 in an average, that is also a constant, which is generally is G, acceleration due to gravity, which is 9.8 meter per second square. This is a dimensional constant which possesses some value and the unit. But that is a dimensionless constant. The dimensionless constant is completely different concept. It is the ratio between same quantity which has no unit, that is called dimensionless constant. That suppose I will be divide the ratio between 2 objects, just like in a right angle triangle. If this is, suppose this is 3 centimeter and this is 4 centimeter, just you imagine this is a 5 centimeter. Suppose this angle is theta, but theta has a secondary physical quantity according to SI system, but when we will derive that is sin theta, that is equal to 3 cm by 5 cm. So cm is cancelled. The ratio which is obtained between the same quantity is purely a number, which is called dimensionless constant. Next we will switch to dimensional analysis, where it is used and how you can use this, how to find the dimension of a physical quantity. Basically there are 2 types of quantity as already I have explained to you. One is fundamental quantity. So now already I have explained to you there are 2 types of physical quantity. That means the fundamental physical quantity, another is derived quantity. That fundamental physical quantity and the respective units are called as fundamental units. and another derived physical quantity, and the respective units are called derived units. For example, I am going to use an expression of all the derived quantity in terms of fundamental quantity are called dimension of that quantity. For example, I am going to say, just like we are defining speed of an object is distance by time. So speed is a derived quantity, and which depends on the distance as well as time. Distance you can measure in terms of length, that is SI unit is meter per second, there are SI units. So that the distance is measured in meter and time is measured in second. So we are now going to express, this is in the MLT form, which is called dimension of the speed. In this case, mass is absent. Therefore, m to the power 0, meter is in the numerator, so it is L to the power 1, time is the denominator, therefore t to the power minus 1. According to exponent rule, when the denominator is changed to numerator, then power become minus. Therefore, it is m0 L1 t to the power minus 1. Now I am going to give another examples. Just like force. Force is a derived quantity whose mathematical formula is mass into acceleration, and its SI unit is kg meter per second square. Kg meter per second square. Now we are going to express this derived quantity in terms of fundamental quantity, and we have to write in the form of MLT, that is called dimension of the force. So mass is equal to m, just like I am writing mass, but acceleration formula already you know that velocity by time, then mass, velocity is distance by time, then d by t square. If we will express in terms of dimension, this is equal to m to the power 1, L to the power 1, t to the power minus 2. That is the dimension of this force. Dimension of force, and its SI unit is kg meter per second square. So in this way, there are so many dimension formula is given. That one is given frequency. Frequency, number of oscillation made in 1 second is called frequency, and its formula is f is equal to 1 by t. That is only the time. Therefore, its dimensional formula is m0 L0 t to the power minus 1. Just like acceleration, speed, all the dimensional formula is given here. So you can study. If you have any doubt, then you can ask me without any hesitation in the next class. Already as you derived the dimension formula for force, mass into accelerations, and already I have derived. If you refer these things, the dimension of area is m to the power 0, L to the power 2, t to the power 0, and dimension formula volume m to the power 0, L q t to the power 0, and dimension formula of density m to the power 1, L to the power minus 3, t to the power 0, and dimension formula of speed m0 m to the power 0, L to the power 1, t to the power minus 1, and dimension formula of acceleration m to the power 0, L to the power 1, t to the power minus 2. Then the dimension formula of force already I have derived in this blackboard, and that is m to the power 1, L to the power 1, t to the power minus 2. And the dimension formula of work m to the power 1, L to the power 2, t to the power minus 2. Similarly, the dimension of pressure and heat, gravitational constant, frequency, stress, power, momentum, impulsions, that you can able to derive. If you are unable to understand, then you can ask me in the next class. Then we will be switched to next concept. Proceed to next key point, what I explained to you. The different system of unit I have explained to you, that is CGS, MKS, FPS and SI. SI is the international standard unit systems which is used in worldwide, and it is said it is the important to know SI unit of all fundamental quantity. In SI system, mass, length, time, temperature, electric current, luminance of intensity, amount of substance are fundamental quantities. Other quantities are expressed in terms of fundamental quantity are called derived quantity. Next important question, what is, write the dimension of potential difference. Potential difference, as already you know, amount of work done in bringing from one point, that is potential difference is the difference of potential between 2 points, and potential is defined as amount of work done bringing a unit object from infinite to a point where you want to calculate the potential of a system, whether gravitational potential or electric potential. By using that electric potential, that is work done by charge in case of electric potential, you are able to calculate potential dimension of potential. Then power, as you know, rate of doing work, that is power which is work done by time, that by using this formula you can able to calculate, that is power is equal to work done by time. Work, already you know, work is equal to, generally you know, force into displacement. Then you can use this formula to calculate first the dimension of work done, then use this dimension to calculate the dimension of power. Next, and SI unit of power that is work done by time, that is joules per second. That is SI unit of power is joules per second, or it is called as watt. It is called watt. So next, the SI unit of dimensional gravitational constant, that I am going to explain you that formula so that you can able to calculate, that is the dimension as well as the SI unit. According to gravitational law, force is equal to G m1 m2 by r square. F is the force, m1 and m2 are the mass of two objects, and r is the distance between the two objects. That means this is the mass m1, another mass is m2. Suppose they are separated by a distance of r. Then this formula, the force of attraction, can be calculated by using this formula. By using this formula, you can able to calculate, that is the gravitational constant G, dimension as well as SI unit. From these expressions, G is equal to F r square by m1 m2. So SI unit is Newton meter square per kg square. Then you can able to find the dimension of this gravitational constant. Distinguish between MKS and SI system, already I have explained to you, and you can refer the manual or the study material. In this case, in MKS system there are 3 fundamental quantity, and SI system there are 7 fundamental quantity. And mention the dimension formula of work, already I have explained to you in case of power how to calculate the dimension of work.